You know, out there in the vastness of space, you've got these incredible star clusters. They're like these glittering families of stars, all born together from the same cosmic cloud. And we're going to look at one today that honestly seems pretty ordinary at first glance, Messier 48. But as you'll see, this unassuming little cluster, it holds the key to answering a really big question.
And that question is pretty fundamental. How does a family of stars actually live? And, well, how does it die? I mean, to really get the grand story of our own galaxy, we've got to understand the life cycle of these clusters, what shapes them, what tears them apart. To find those answers, you need the perfect cosmic laboratory. And it turns out, Messier 48 is exactly that.
So where is this incredible lab? Well, it's about 2,500 light-years away. That's a pretty good hike. You can find this brilliant collection of stars glittering right there on the border of the constellations Monoceros and Hydra. What's so great about that spot is that it's close enough for us to get a really good, detailed look, but still far enough away to be this whole other world.
So, our subject is Messier 48, or M48 for short, and it has a pretty wild history. You see, when Charles Messier first cataloged it way back in the 18th century, he messed up. He recorded its position with a 5-degree error. That's a huge mistake in astronomical terms. So for years, astronomers were looking where he said it was and found absolutely nothing. They thought it was a phantom object, a total cosmic case of mistaken identity.
All right, so here's what we're going to do. We're going to dive deep into this cluster's secrets. We'll look at how it's being ripped apart by the galaxy, how we can tell its age just by how its stars spin, and even check out its unique chemical fingerprint. Stick with me, and you'll see why M48 is such a big deal, a true cosmic benchmark.
Okay, so first up, a star cluster's secrets. Let's really get into why M48 is the perfect case study for astronomers who are trying to piece together this puzzle of how star clusters live and die.
See, the real challenge for astronomers is finding a cluster that's in that Goldilocks zone. Not too young, not too old. A lot of clusters, they just don't make it. They die young from something called infant mortality. Others are way too old, and all their secrets have already scattered to the cosmic winds. But M48? Oh, it's just right. It's at this perfect intermediate age where we can see the processes of its life and its eventual death happening right now.
So let's start with the big picture. Our first major clue about M48's fate comes from looking at its large-scale structure. This is what we're calling the Great Galactic Rip-Apart.
Okay, so first, a quick refresher on what we're even looking at. M48 is an open cluster. Just think of it like a loose group of sibling stars. They were all born from the same giant nursery of gas and dust, and yeah, they're held together by gravity, but only just barely. That's the key point.
Now this is where it gets really interesting. For a long time, we kind of thought these clusters were just simple, uniform balls of stars. But when astronomers took a super close look at how the stars in M48 are actually moving, they found something wild. A 2016 study found something they'd never seen before in any star cluster, a clumpy, fragmented structure. And not just in where the stars are, but in how they're all moving together. It's a huge discovery.
So what did they find? Well, they identified 3 separate cores inside M48. You've got the 2 main ones, C1 and C2, which are kind of the heart of the cluster. But then there's this third one, Core A. It's fainter, not as dense, and this is the crazy part. It's actively detaching. It's moving away from the others. We are literally watching M48 lose a piece of itself.
So what's going on here? It's a cosmic tug-of-war, plain and simple. M48 is in this constant battle for its own survival. As it orbits the center of our Milky Way, the galaxy's massive gravity is pulling on it, stretching it. These are called tidal forces, and we're seeing it happen. This is the slow, inevitable process of a star cluster being ripped apart, piece by piece.
Okay, so we know the cluster is being pulled apart. That kind of begs the question, right? How old is this thing? Well, to figure that out, astronomers have this incredibly clever technique. And believe it or not, it all comes down to how fast a star spins.
This amazing technique is called gyrochronology. And the idea behind it is actually pretty simple. Think about a spinning top, right? Over time, it slows down because of friction. Stars do the same thing. As a star gets older, its rotation slows down because of something called magnetic braking. So, if you can measure how fast a star is spinning, you can basically tell its age. It's like a cosmic clock.
So how do we use this clock? We compare M48 to other clusters that we know the age of really well.
When you do that, it becomes crystal clear. It's definitely older than the M34 cluster, which is about 250 million years old. But it's also definitely younger than the famous Hyades cluster, which clocks in at 625 million years. M48 sits perfectly in the middle, our perfect benchmark. The tool scientists use for this is called a color period diagram. It sounds complicated, but it's not. All it does is plot a star's color, which tells you its mass, against how fast it's spinning. And what you find is that all the stars in a cluster of the same age fall along a really neat line. For M48, that line sits perfectly between the line for the younger M34 cluster and the older Hyades cluster. It's like a perfect timestamp.
So what's the final verdict? Well, this whole gyrochronology thing gives M48 a really precise age, 450 million years, give or take about 50 million. And that number is so important because it confirms that M48 is right in that critical transitional phase. It's not a baby anymore, but it's not an old-timer yet either.
Okay, so we have its structure and we have its age. But to really truly understand the story of M48, we need to go even deeper. We've got to look at the chemistry, what these stars are actually made of. Because inside the fiery heart of every single star, there's a story being written.
And believe it or not, that story is written in lithium. Now, lithium is a really fragile element. It gets burned up and destroyed super easily inside the hot core of a star. So the amount of lithium we can still see on a star's surface, that tells astronomers a ton about what's going on inside and where that star is in its life story.
And here's the chemical proof that ties it all together. When astronomers measured the lithium in M48 stars, they found a pattern of lithium burning that was, you guessed it, perfectly in between the younger Pleiades cluster and the older Hyades cluster. This is a completely separate piece of evidence that tells us the exact same thing. M48 is in that vital, just right stage of its life.
So let's bring all these different pieces together, the structure, the physics, the chemistry, and look at the big picture. Why is M48 so incredibly important?
Well, this cluster that seems so ordinary is actually anything but. First off, it's a live snapshot. We're seeing a star cluster being torn apart by our galaxy in real time, which shows us exactly how these things die. Second, its perfect middle age makes it a crucial calibration point for telling the age of stars all across the cosmos. And finally, that clear chemical fingerprint makes it the perfect laboratory for testing our biggest theories about how stars live and evolve.
So the stars of M48 are slowly, one by one, breaking free. They're going to wander the Milky Way all on their own. But their story isn't over, not by a long shot. They still carry the memory of their family with them, in how they move, how they spin, and what they're made of. And as they scatter across the galaxy, they leave us with a new question to think about. What secrets will they tell us next?